Welcome back to Digital Trends Live. I'm Greg Nibbler, and thanks for joining us. Hit that subscribe button on whatever platform you're watching on, that we get the notification when we go live. We get to have some really great conversations here on this show, and certainly technology for space is something that we've been talking about a lot. We see a lot of companies with renewed interest on getting humans to other planets and the moon and other places. But what are they going to live in when they get there if we set up these habitable structures and zones? Well, that is what we're going to talk about right now. Joining us, we've got David Malott, who's the co-founder and CEO of AI SpaceFactory. Thank you so much for being here with us. Really, really excited to have you here.
Thank you, Greg. Delighted to be here.
So, David, to give everybody a little bit of backstory, can you tell us about what AI SpaceFactory is and what some of the things are that you've been working on?
Sure. So we've been working with NASA for about 2 years now, looking at technologies to build on the moon and Mars.
So looking at this, to build on the moon and Mars, I mean, that's a big statement right there. So when you talk about that, are we talking about structures and different things that people would be living in and working in? Is that what we're talking about?
Yeah. So, the habitats for people to live in, but also the infrastructure. So things like landing pads, roads, berms, and anything you need to create a sort of sustainable presence off-world. So I think what you're looking at on the screen right now was our design proposal for a Martian habitat, which we call Martia for short. The thing about Martia and the whole premise of the technology is that it's 3D printed from material that you can harvest from the Martian surface, or in the case of the moon, from the lunar surface. It's a particular type of rock called it's basaltic regolith is the technical term, and to use the rocks that you find on the planetary surface as your 3D print material. So this is not like your desktop 3D printer, which uses a plastic. It's actually a little bit of plastic in there to bind the crushed rock together. That material is heated up and then 3D printed to create any kind of variety of structure.
So it's actually harvesting this rock, which would be important to harvest the materials that are already there. But then did you say that it's melting the rock itself? How does it actually make the rock malleable enough to be 3D printed?
So we still need a what we call a binder. So the material is a composite of the crushed rock and a polymer binder. So, we're looking at different sources for where the polymer comes from. One source is just mission waste, plastics that are used in space. So, for example, on the ISS, there's a sort of whole list of plastics that are being used there. So, thinking about ways that we can take space waste and then use that, combine it with, the Martian or the lunar rock as the binding material. The other possibility, which is quite interesting, is actually synthesizing the polymers on the lunar or Martian surface. Either harvesting by growing algae, so you can make biopolymers from that, or actually synthesizing it directly from volatiles that you might capture, from these shadowy areas on the moon, where NASA scientists believe that you can unlock CO2 and then other other chemical compounds that we could then use to create the polymers.
Well, just that ability to utilize so many different kinds of materials, I mean, that's certainly a huge advantage for something like this. Now, with something that we're taking a look at there, say this does get up and going and it's on the surface of the moon, how long does it take to actually print out one of these buildings?
Well, you're looking at the prototype we printed for the NASA Centennial Challenge. And we printed this structure, it was 15 feet tall, in 30 hours. Okay, so 3 print days
Wow.
of 10 hours each. So it's pretty fast. Now, this is obviously a prototype. There's a lot of development that needs to take place between now and then. Obviously, here we're printing indoors in kind of comfortable Earth environment. Printing on the moon or Mars would present entirely different challenges. But the interesting thing about this, and you can see it's made with what we call Mars relevant material, because obviously the material is actually not brought from Mars, but it is made out of the same materials that you can find on Mars, and it's super strong. That last image you saw was a caterpillar excavator trying to crush down on this Martian egg, and it resisted the force of that excavator. So there's something about the shape, which is highly optimized. So it can be strong, even if it's kind of like, relatively like the thickness of an eggshell. So super strong material.
Wow.
Yeah. So it's like very mass optimized, but the material is stronger than concrete. So it's great
Um,
stuff. So
Oh, I was just going to say, I mean, this is really exciting stuff that you've got here. And as we see more of these space agencies and even the commercial aspects of it, aiming towards getting humans back to the moon and then to Mars, how far off do you think that we are before something like this is actually going to be able to be utilized on, say, the moon?
well, definitely Moon is the next target before Mars. NASA's prepping to go back to the Moon in 2024. So we're gearing ourselves up to do a lunar surface demonstration, which would really be the first time that anyone has printed off world but to get there, we're still going to need to test the technology in incremental steps in more and more lunar-like conditions. So first in a vacuum, and then in a cryogenic vacuum, and finally in microgravity. But it's really only on the surface of the moon that you're going to get all these environmental conditions working together. So that's the only time that you can really validate this technology.
Once it does, get to this point where we have these things built on the moon, and we get to there, is this something you would be wanting to go live in yourself?
Well, I think we'd have to do a lot more work before I would even, I guess, myself have the comfort level to trust it. I think, we would start by printing the simpler stuff. We call it a non-pressurized structure, so like sheds and stuff. And then it's there's a lot of components that have to come together, and then you have to just like on Earth, you just have to make sure that the building can last long enough, and you need to test things. So that would be the first phase. And then you go on to building the more complex structures, which are these pressurized structures, which are really more life critical. And then, sort of in parallel to developing the technology for space, then we can also build it here on Earth. And so if you think about that whole premise about using the raw materials on the moon or Mars as 3D print material, you bring that concept to Earth. It's suddenly a very, very sustainable way of building, because you're not having to manufacture steel, you're not having to manufacture cement, which are these very, very energy intensive materials, but you're just building with Earth as raw material. We want to get the power requirements down. I think by thinking about the space case, like you're really having to develop your technology to be like hyper material optimized, hyper power optimized, which means that if we're successful in doing this, then on Earth we can have a scenario where we're printing with solar power. So it's the material itself is sustainable. The energy that's used to power the equipment can also be from renewable resources, and that's ultimately where we want to get with the technology on Earth. And so Earth is where we would build habitats first, okay, and prove them out, test them at that full scale to make sure that they can be completely airtight, that they can be pressurized.
Right.
So I'm not going to kid you, this is not something we'll be able to do tomorrow. It's going to take a lot of knowledge development, but nonetheless, we feel we are on our way.
It's really exciting stuff what you're doing with this, and I love all the advancement in all of this. And this is this is really making the building blocks in maybe a literal sense of what we'd be living in there on this and with this technology. Thank you so much for joining us here on the show to talk about this. It's exciting. I can't wait to see where you go with it and what the next steps are going to be. And everybody can follow along right there, AISpaceFactory.com. And David, thank you for being here on Digital Trends Live with us.
Okay, thank you so much, Greg. My pleasure.